Now, the next thing, last thing is what is uh, happening if I have three phase? Because we don't want
Beautiful.
single phase. So if you have three phase, I have three such converters. And what happens with that is that each phase has its sine wave current drawn in a phase with the sine wave voltage, and there are
Nice.
three phase sine wave currents. And what is then the result? The product of each of these phases is that it's a product of sine wave voltage, sine wave current. This power, instantaneous power of each of the phase is fluctuating. You see, it's fluctuating with twice the frequency of 60 hertz, 120 hertz, and DC level. But now, if you have it in a configuration like this, DC level of three phases add together to get to three times DC power. But what happens in three phase that Tesla invented? Three phase currents now are like three phase currents in Tesla system. So three phase currents are DC with a sinusoidal current superimposed. So three phase currents, DC currents add together, but three phase currents add to zero. Beautiful. Then now if I have a three phase converters operating from a three phase line into a single load, rectified load, three phase current cancel. Why is that important? I don't need the 60 hertz filter because single phase requires 60 hertz filter to filter out the whatever ripple. But now I don't have, I have an output which is the three phase 60 hertz currents cancel, and all I need is 100 whatever is switching frequency to have a ripple switching frequency capacitor on the output. So there is no need of big capacitor either. So that is here. And that was a question that was mentioned, and I mentioned before. Uh, when I looked at this, this was one problem which I had with this, and we implemented. I needed a two-quadrant converter. I needed this switch, the single switch, to operate in the first quadrant for a positive sine wave and a third quadrant for negative sine wave. But there is no switch, single switch, which does that. So I have to fake it with this composite switch, which had the two MOSFET switches at the top of each other and a drive, which is between, and these two are back-to-back MOSFETs, and the emitters are connected together, emitter or sources are connected together at this point, and you have to have a floating drive to drive these two switches because it's a floating, because you're driving it between the drive and this common point, which is between two switches. Or you can have two IGBTs which have a reverse capability and then put them in parallel. So each IGBT has an effective diode in series with it, and then putting two in parallel will affect main switch, which is waste. So really what we need ideal switch is this voltage bidirectional switch, which makes sense, right? If you have AC line input, shouldn't this switch be able to work on AC line, right? That's what it is. So now we do have this Panasonic, and someone in an earlier lecture mentioned that Panasonic was sold to some other company. So appreciate sending that information so I can contact them and implement that with this gallium nitride switch with the two gates, which then one gate operates in the first quadrant and the other gate operates in the third quadrant, and that everything else is the same. And so this is my charger, and if you put there with this, and this is my, usually I like to put it on a healthy note, and this was here, question. Dad, how did you do that? Like in the style of the, what is this? Richard Sherlock Holmes, you'd say. And he said, elementary, my dear, I started working on it. Now it is actually 50 years, not 40 years ago. So, in conclusion, alternate gets current, and of course now this can be also made bidirectional. You can charge during the day, AC to DC charger battery during the night. During the day you are charging, and then during the day you can use the battery with the stored charge, if you have enough stored charge, to send the power, AC power back into line. So because at night charging costs you much less, and power at the night is costing much less and is more expensive, 5 times more expensive during the day. So that each time I come up with new invention, I sleep, go to sleep and talk to Tesla and check with him and says, do you agree with what I did? And then if he says yes, then I fall asleep. If not, then I have a sleepless night. Okay, so that's all right. So that's the end of the today talk. And today I think we'll have one thing. I have to do something personally, and I have to be someplace by 10:30, so I can have a bit reduced discussions to maybe, since my appointment is 10:30, although it's closed, but still in 10 minutes together. So feel free to ask any question related to that. I will try to put this stuff on email, basically. Hopefully we'll get by tomorrow morning, we'll get the editing of these presentations and post it as attachment to the email. And hopefully you can use this attachment to tell the rest of the world, come and join and don't ignore it, okay? I want to see more of you because it really depends on that. If more of you showed up, I am motivated to, as you see, I'm motivated anyway, motivated to these lectures. If not, then I'm a bit offended here because I stay every time after 2 hours, I stay an hour and a half, and half of you leave. So so I feel like I'm not needed, because you have more important things to do. And I thought the most important should be now that you sit on this course and learn, okay, and ask questions. So anyway, go for it.